Welcome back to the channel, guys. Today we're going to be focusing on venting, more specifically venting for the fuel cell surge tank and venting for our 8.8 Ford Explorer diff and how to come up with a unique mounting solution for both. Now this is everything we're working with. It's a radium filter. They include a 3/4 barb adapter fitting, and this is my Ford 8.8 Explorer diff housing barb fitting adapter. It's a little bit cracked, crusty, and trying to adapt this small of a barb fitting into a filter just isn't going to work. So the goal is to figure out how to adapt this large of an inside diameter down to this small barb for the diff, and how to adapt this filter down to an 8AN fitting on the fuel cell surge tank, and how to cleanly mount it in the trunk area and include the loops required to maintain proper venting and no fuel spillage. So let's go over to CAD and figure out how this is going to happen. Now, it wouldn't be me if I didn't overmodel everything for a simple little bracket, but here we are. This is my assembly for the rear that I've had for a long time, and it comes in handy for projects like this where you have a little bracket and you just want to mount it up to an existing product that you've already sent out to send cut send and know is good. You know, it's just a way of getting around the 3D printing thing. So gain confidence, define your clearances, and just ready to hit go. So this is what I got here. So I modeled the filter from radium, and then I'm adapting to, if I make this transparent, I'm adapting to a 3/4 barb that I'm cutting down. So the ones they sell on Amazon are long, so I'll cut this down to a single barb, and then I'll weld that to this bottom plate here, and then on the bottom side I'll just weld the AN fitting. Unfortunately, I don't sell a bulkhead AN to barb fitting. That'd be kind of cool. So just make my own, and by splitting it up this way, it allows me to weld it out without running into fitment issues with my cup or anything. But yeah, so now this 8AN will go down to the fuel cell surge tank, 6AN will go down to the diff, and the way that I'm adapting that 6AN to the diff is through a very OEM-like adapter. So I took all the geometry from the bottom and copied it, and then I added a larger barb fitting for the top. So now this matches the proper barb sizing for the internal diameter for a 6AN fitting. Now, how am I going to make this? I'm not a big fan of just using a traditional FDM 3D printer for things that actually go on things that I care about. For automotive stuff, especially outside of the interior, I like to go with HP, the printer company. They make multi-jet fusion lasered 3D printed parts. So it's a powder sintering process, super nice, super strong parts, very heat resistant, resistant to a lot of different fluids. So that's what I'm going to do this in. It's fairly cheap. It'll be under 50 bucks for 10 of these. So I like to go through Xometry or Proto Labs, Hubs. You can get a lot of places to outsource these things. So check that out sometime. But yeah, the overall bracket design itself, one thing I wanted to hit on before I send this off to send cut send is just looking at their parameters when you go to make something simple like this can save you a little bit of a headache. So big thing right off the bat, defining your K factor and your sheet metal thickness and your bend radius. So if you go to Send Cut Send's website and you go to materials, metals, I know I want to do this out of 5052 aluminum because that's what you use to bend, or that's the bendable aluminum. It doesn't crack. It's 1/8 inch thick. You go to their tables and you find their effective bend radius at 90, 125, their K factor 0.44. Put those in here, and then it'll bend it in CAD the way that they will be bending it with their specific die width and bend radius and everything. So speaking of die width, if I flat pattern this thing real quick and I measure from the center of the die line to my feature, my cutout feature, this distance is 0.441. The goal here is that your parts should always be within the die width right here. So 0.630 is the die width. You need this distance to be greater than half that die width so that this doesn't result in any deformation or any other issues as it gets bent on that die line. So there's some tricks to kind of get around some of that stuff, but I just try to keep my features outside of it. But that's it. We're ready to go and send this thing off to Send Cut Send, and it should be about 5 days to make it. I got plenty of other stuff to do on the RX7 while I wait for those 5 days. But once those parts come in, we'll get back after it. All right, it's been about a week since we placed our Send Cut Send order. Everything turned out super nice. And like I mentioned in other videos, sometimes if they're bending two of one thing, they'll just bend an extra in case there's an issue and they don't have to go back through the process to laser cut another one, get it bent. So this is the fastest way to get things to you. So we got a bonus. We got 3 of these things. And we've got plenty of hose and fittings from Vibrant. So this is our 8AN, 6AN hose, and got a bunch of their fittings. I always try and stick with Vibrant. It's definitely one of the best quality brands that I've worked with for fittings. And we've got some cheapy Amazon weld-on fittings because I just had them, and 3/4 barb fittings that we're going to cut up. So like I mentioned, we're going to cut these down so it's just one barb. And our exometry or zometry order, got 10 of these things for around 40-ish bucks shipped, which isn't too bad considering it's not a material I can make at home or do at home. So I think first step is to try and fit this up and make sure it works. Here's a look at the difference between the OEM Ford fitting and my fitting. Quality is super nice with PA12 as always. But I've already done a test fit and realized this is now too large. And that might be why this was cracked from me putting in the 8.8 Explorer Ronin adapter. So because of where that hole is and its relationship with that wall of the bracket, it's really tight. So when I put this thing in there, I gotta have the flat edge facing the bracket. Slides in real nice, but with that shaved edge, it's showing me just how close this thing is to the bracket. I would not have any room to slip a hose over that. It's almost perfectly touching that wall of the bracket. So what I need to do now is to revise this, unfortunately, and turn this into a 45 out, and that way I can get my hose on it properly. That's just one of the things that happen when you increase the diameter of this. Even the OEM one just would have been super tight with a hose. So that's all right. I rarely get things right the first time, so we'll just revise this to a 45 or 90 and go from there. But in the meantime, let's get our bracket welded up and we can mount it to the firewall. Here's our Send Cut Send pieces fresh out of the box. Everything fits up super nice with the tab and slot feature. That 10 thou clearance that they recommended in their guidelines is perfect. It allows for it to be nice and tight without falling off. So this thing should be a breeze to weld. One thing to note about laser cut parts is that there will be lead in and lead out lines. It's just inevitable. One thing that you can't request it without it or have post-processing done. You can do tumbling, which can help with that, but it'll still be there. So one thing I like to do with these parts is I like to put my own finish on it typically with red Scotch Brite and a DA after taking these down a little bit. So I'll just clean up the edges a little bit, and once that's done, I will go ahead, hit these 3/4 push lock fittings with the bandsaw, cut off those 2 barbs, and that way I can start welding this guy on, and then I can weld my other fitting on the bottom. And I've got this sized perfectly for the hole, so should be a piece of cake to weld this thing on. The one thing I will say about these Amazon fittings is that they sometimes have a little bit of anodizing on them or coating. So it's always good to hit them with some Scotch-Brite, sandpaper. I typically opt for red Scotch-Brite for everything, and should be good to go and ready to weld after that. So let's get to it. So aside from some acetone, this thing's ready to weld. I got the two fittings welded on, and I'm using what's called a machinist jack to hold it up. That's what this thing is here. You can get them on Amazon, but I built these like 10 years ago on a lathe, so should be pretty well fixtured now to go ahead and weld this out. And that does it. Fully welded out. Gave her a good red Scotch Brighten, and turned out all right. So now the real test is seeing what it looks like on the firewall and getting this thing lined up straight. So I think what I'm going to do is put on the filters so I know my max height. Like realistically, I'll probably keep it pretty low, and then get some fittings on here and start building out some lines. Super easy to get on here. Yeah, we might need some lube. One thing I found pretty helpful to leave set up all year round is just this tripod with a laser on it. I use it in the house a lot for home projects, and then I always find a use for it on the car. And it's nice because I can just line up the center dot on that radium fill cap and the center dot of the bolt hole for the convertible top. And I know that's exactly center where I need it. And then that horizontal line is the line that I'm using to match up where I want the top. So now I have level, and I can just line up my center point where the center of the triangle is. I know that's exactly center, flat with that line, and we're all squared up. So I'm going to mark out my holes, and then we can center punch, center drill, drill, countersink, the proper order, and we'll be done. There we go. Looks nice and centered and square to me. So I started putting my fittings on. I've got a 6AN 45, goes down to the diff, no problem. I do need to wait for that new updated 45-degree fitting for the diff. And then I'm looking at these 8AN straights that I bought, and I'm thinking that's probably not gonna work. I've got this softer hose just for mock-up and reference, but if I were to go straight to straight, I'd be kinking the crap out of this hose. So even if I did a 90, which I don't have a non-PTFE version, but for mock-up's sake, if I did a 90 here, and I wrapped this stuff super tight, to get it to go where I need to go is pretty challenging. It's just such a tight, such a tight fit. I don't know, I guess I could do that. But honestly, I'm kind of leaning towards tube. Just do 8AN tube nuts and hard line. But I don't already have hard line. I don't have the crimper. Or I don't have the flare tool, I mean. I don't have the tube ends. It's just more money when I have almost everything I need right now. I don't know, I'll think on that. All right, guys, it's been a few days and we've got a new solution, and I've already finished it. This is the way that things go sometimes. Unfortunately, I had to completely remake this bracket and switch 8AN to be on the right side and 6AN to be on the left side. And that allowed me to run this 90 and this 90 that are almost in line so that I could make my little hose loop setup. So a little complicated trying to figure out where the hell this needed to be to come up with a somewhat clean solution. I really didn't want to go with the hardline setup since I had all the materials here. So that's it. I'm calling it a wrap for this. I've got my 45 down there in the diff that turned out pretty damn good. And now we have a fully vented system. All right, that's gonna do it for this video. As you can tell, something that sounded super simple ended up being a little bit more work and waiting on parts to arrive. And that's the way things go with building race cars. But stick around for the next video. We're gonna dive into all of that ECU, PMU, CAN hub mounting in the next one.